All right, everyone, it looks like we have pretty much everybody we're going to get for today. Looks like a good portion of the attendees decided to wait for the recording for this, but for those of you who are here, thank you for coming, and we'll go ahead and get started here. Welcome to another of our LabChart Mastery series. Today we're going to discuss using the stimulator in LabChart. My name is David Ream. I'm the Technical Support Engineer for AD Instruments North America, and I am based out of our Colorado Springs, Colorado office. And before we get going, we're going to kind of talk about a few intricacies of the webinar that you've probably noticed already, and maybe a few other things that we've had customers ask us about recently, just that we just want to make abundantly clear to our customers. So first of all, webinar guidelines. You probably already noticed that your audio is muted for all attendees during the presentation. This is to kind of keep background noise down, to keep questions at a minimum while I'm presenting material. If you do have questions during my webinar, please enter them via the GoToWebinar toolbar. And if you're using a Macintosh, the screenshot here on the left will be what you'll see. If you're using a Windows machine, the little screenshot here on the right will be what you're using as well. So pretty similar, same basic interface. Like I said, you can either enter your questions in the questions box, or if you'd like, you can do them in the chat window as well. And I will answer them in the turn that they were asked during the webinar at the very end. And before we get too far as well, I want to talk about our training calendar. These are actual physical courses that you would come to, and we do charge for these. We actually have a LabChart software training course coming up here on the 28th and the 29th in Boston, but we'll wait to actually register for that one and travel. But we do have another one coming up on the 5th and 6th of December this year, and also the 12th and the 13th of December this year. They cover what we cover here in the webinars in much greater detail. It's a 2-week course, and basically it'll take you from, starting out basic amateur with LabChart, and you'll be an expert by the time you leave. And we try to tailor these too for all the attendees that show up. We do little questionnaires to figure out what your applications are and try to gear like the LabChart modules that we present towards what you'll actually need for your research. And my apologies, the one coming out here on the 12th and 13th is at our Colorado Springs location, and then of course we have another one coming up in Boston on the 16th and 17th of January 2013. And if you're ever curious about what else might be coming up, please go to www.adinstruments.com/events. And we'll also want to talk about upcoming LabChart Mastery webinars. Currently we only have one on our schedule, but they'll just keep checking back. More and more will be added. So we'll discuss advanced arithmetic calculations on the 11th of December, and Brand Boucher will be presenting that one. And once again, you can also go to www.adinstruments.com/events/, and that will tell you what's coming up, and also just kind of talk about other events we may be holding. And like I said, we're going to kind of cover some things that customers have asked us about. What can we use your equipment for? What can we use the software for? Out of all this verbiage that's up here on the screen, the thing to take away is the PowerLab and our associated products are not intended to be used as medical devices or medical environments. Can they be used in a medical research environment? Yes, but they cannot be used to diagnose or treat a disease, an injury, anything in a patient. They're designed purely for research. They are not for clinical use. So that's the kind of take-home message from all this that's up here on the screen. And how do I know if my equipment can be connected to a human safely? How do I know what do the different symbols mean? So for body protected, so it can have direct connection to a human. You're going to see off here to the very first one. The little stick man person here, that means that you can connect it. You'll see this on the front of our bioamps. You'll see this on the front of our stimulus isolators. Anything that's safe for human connection, you'll see this symbol. As far as cardiac protection, direct electrical connection to the heart, there is very, very few pieces of equipment can actually do this. I believe off the top of my head, and don't quote me on this, I believe our blood pressure amp is one of the very few ones that does, but double check that on your equipment before using. It may not currently have that certification anymore. So once again, if you're curious about how to connect things, these are the symbols you need to look for. I also have people tell me, well, how do I know that what we're ask me, I should say, how do I know what the PowerLab is telling me is accurate? AD Instruments is certified by the ISO 9001 quality management system. We spent quite a bit of money to get certified this way, and to actually, this is our handshake with you, or our verification with you that we design, manufacture, and service our data recording instruments and software according to this standard. In other words, we follow this standard so that you know what you're getting out of your PowerLab is really what's being input to it. So just if you're curious about more about this quality management system and what it means, ISO 9001 does have a website, and you can actually review a lot of their documentation for data recording instruments and software. So now that all the preliminaries of the webinar are out of the way, we'll talk about what our program is today. So first thing we'll talk about is do kind of a general overview of what the stimulator is. Then we'll talk about settings, how to configure it for specific applications, and the various intricacies of how to set it up. We'll talk about some of the customizable waveform options and also the arithmetic stimulation settings. So first thing I'll talk about is an overview. What is a stimulator? What does it do? The stimulator is the name for the software interface that LabChart uses to control the analog outputs on the front of your PowerLab. Here we have one of our research series, the new 35 series that we actually just come out with not too long ago. And on the left-hand side, you'll see the trigger input, and then you'll see output 1 and 2. These are the analog outputs, basically ways that LabChart can tell the PowerLab to send out a specific signal, and that signal will come out of these points as a constant voltage signal. For my webinar today, to kind of show you what things do, I'm going to connect those outputs to input 1 and 2 on the front of the PowerLab with BNC cables. This will allow me to kind of stream back in what we're doing with the analog outputs via the stimulator panel and settings window. That way you can kind of see the changes and see what waveforms we're generating, how they all work. And without further ado, we'll go ahead and open up LabChart. So that's what it controls, but what can I use the stimulator for? There's a lot of different things you can use the stimulator for. You can use it to control external equipment. Say I have an MRI machine or some other sort of imaging system. I want to actually tell it to do specific things, either manually or via some automation in LabChart. We can use the stimulator outputs to do that. Say I have a tissue in a tissue bath and I want to stimulate it with a constant voltage signal. I can use straight out from the analog outputs of the PowerLab. I can go straight to that tissue and use the stimulator settings to actually control that. We can also drive a constant current isolated stimulator, like our FE180, that is a human approved for connection, and that way we can send out a constant current stimulus to a subject or a tissue. So where are these stimulator settings and panels that I'm talking about? If we go to Setup, and if you have a PowerLab connected, you will see that there's the stimulator option and the stimulator panel. Once again, it's under Setup, Stimulator, and Stimulator panel. If we click on the stimulator option, it brings up the main stimulator settings window. All of your in-depth settings options are going to be available within here. What is the panel that I'm talking about? So once again, to bring up the main stimulator settings window, all I do is click the stimulator option. But what does the stimulator panel mean? The panel is more of a shortcut. In comparing the two, we have the panel here on the left. In the settings window here on the right, you'll see there's a lot fewer options available here. What you see here, we can customize. We'll talk about that later. But this is just kind of a way for you to have a shortcut while you're recording. If you want to change specific things in your stimulus, you can do that here very easily. It's only what you really, really need to see whenever you're actually doing your experiment and things you need to change instead of all the other parameters that are kind of cluttering up the view and might kind of distract you or confuse you while you're in the heat of the experiment. So like I said, it's just this really simple way for you to adjust the parameters that you need to adjust during your experiment while you're recording. Once again, setup, stimulator is the more in-depth settings, and stimulator panel is the kind of shortcut that allows you to access to only a few specific settings. So the first thing we're going to go into, so we'll go into the stimulator and we can talk about the basics of what's out here. Earlier in an earlier LabChart 7 release, we actually gave you independent control of the analog outputs. So number one, we can control it here, and we can control output to here independently. In previous versions of LabChart 7, I believe it was prior to 7.2, these were actually just differential outputs of each other, and you could not independently control them. Now we can set up whatever waveform we want from each one. If you want to go back to that differential output, so I'm just going to go ahead here and don't be too concerned about what I'm doing. And I'm going to close this. I'm going to start recording. So I have output number 1 going into channel 1. I have output number 2 going into channel 2, two entirely different waveforms. Now, you can, like I said, you can go back to the way things were just by checking this differential checkbox. LabChart will stop recording and then start recording again, and you see it's just a differential signal now of each other. And if we click over to output 2, everything is grayed out, just saying, okay, we have it in differential mode. And then we can go back to our independent. PowerLabs that can do this. Currently, it's only the research series and some of the previous research series. So the 35 series, the 30 series, and the SP can do this. Off the top of my head, I don't believe the 26 series can, but most of the teaching PowerLabs cannot. They're just going to be locked in that differential mode. This is part of it's kind of a hardware option as well as a software option. So the research PowerLabs have that additional hardware that's required in there. Another thing you'll notice is that up here at the top, go ahead and click this off. Let's go back to one specific. You'll see we have the start stimulator options. We can do it when sampling starts, so the minute we hit the start button, we start stimulating. We can have it manually start. So if I hit start right now and I have it set to manually, nothing happens. But whenever I want to stimulate, I have this stimulate button here, and it starts stimulating. And that stimulate button also shows up in our stimulator panel if manual stimulation start is selected. So if I have the panel up, I can go ahead and stimulate, and we start stimulating according to how the stimulator is set currently. And there is one other option, independent of sampling. If I turn this on, LabChart is stimulating as we speak without recording or anything. So if we start and stop, you'll see, unlike whenever it's according to when we start and stop recording, we're cutting off waveforms here because it keeps stimulating. It's stimulating right now. So it's entirely independent of how you're sampling. So if you have a prep that you want to kind of condition with a certain stimulus, but you really don't care about whether we're recording what's happening, you can definitely do it this way. Or if you want to keep it under some sort of constant stimulus. For our purposes of kind of teaching here, I'm just going to go ahead and go back to when sampling starts. And of course, you can see here we have the on and off buttons for the output. Over here is the marker channel. What the marker channel does is it just gives us a little unit spike wherever we used to have a stimulus. So for instance, I'm going to set it up in channel 2. You always, will almost always, I mean, I can't say, I guess, always, depending on what somebody's experiment is or if they want that unit spike on top of the stimulus or in certain areas if they're recording it here. But it's a way for you to know that you're stimulating at a certain point without actually piping things back in like I'm doing here back into one of the inputs. So normally I don't like putting it over raw data, though, is what I'm trying to get at. It can affect it, it'll add to it. It's just not a very good idea. You want to kind of have a dedicated channel to that. So I'm setting up channel 2 here as our dedicated channel for that marker. And if I hit start, you'll see every time the stimulus occurs, and we'll go to something a little different maybe. Every time that waveform repeats, we get a marker saying it's happening every time. And it's just a little unit spike here. So it's a way to kind of keep track of what's going on with the PowerLab and with LabChart. So I'm going to go ahead here and turn it off. You also see here we have this output range option. All this really is kind of a macro adjustment for what's available to you. You can see here it's default at 10 volts. If I go down to 5, you'll see it starts to kind of decrease what's available to me. So you'll see here output range 10. For pulse height, we have this kind of plus or minus 10, or excuse me, this 20, plus or minus 20 option available to us. The baseline is plus or minus 10. We go down to 5, plus or minus 5, plus or minus 10, 2, plus or minus 4, plus or minus 2 for the baseline. So it's just ways to kind of do a large change without it going in here and doing some of the specifics within the settings windows. You also see here, if I have a parameter that does not follow my current limits, and we'll talk about how to adjust these limits later in finer detail, I get this little exclamation mark. If I mouse over it, it tells me what's wrong. Pulse height error. Pulse height of 5 is out of range. Valid range is negative 4 to 4. So there's a lot of built-in options here that give you errors to kind of tell you what might be going wrong. So I'm going to move things back to 10. And then we're going to kind of talk about preloaded waveforms. LabChart, by default, will have from arithmetic here and down. These are some custom ones that I've loaded that we're going to talk about later. But arithmetic, pulse, step, step pulse, biphasic pulse, double pulse, ramp, sine, triangle, those are actually built into LabChart right now. So some of these weren't available before. There's some new ones. If you're a LabChart 6 user and are currently moving up to LabChart 7, or if you haven't updated from an older version of LabChart 7. Very helpful. It's all built in. If I can just simply go down here and say, okay, sine wave, we have our default settings. I hit start, and we get our sine wave coming out of number 1. Okay. So I'm going to kind of go through each individual one here. We're going to leave arithmetic alone for right now. We'll talk about that later. First one, though, will be pulse. You'll see our parameters change here. There's going to be some that are going to be consistent throughout all of the all of the preloaded waveforms. Things like baseline. What does baseline mean? It's wherever we start for our pulse. So right now it's set to 0. So our baseline is at 0. We can set it to 1. And I can either do that manually here with the up or down arrows, or I can use the slider here. We'll go to 1. Hit start, and you see my baseline now for my pulses are 1. And then from the baseline, we go up 5, which would be to 6. Start delay. How long when we start the stimulus does it wait before it starts stimulating? Pretty self-explanatory. We've got default options here of 0 to 10. Like I said, we'll talk about how to change these later. How many repeats? 1, infinite. Do I only want 1 pulse, or do I want 5? Do I want 12? Do I want 13? Or do I want it just to keep sending those pulses out? Max repeat rate, just like it sounds. How fast can these repeats happen? We're set at 1 hertz right now. Pulse height, 5 volts, just the amplitude, and the pulse width is at 100 milliseconds right now. Okay? I'm just going to kind of move down these quickly, and we'll kind of talk about what they are. So take a look at the step pulse as it comes out. Baseline we've already talked about. Start delay, repeats, max repeat rate. The new additions we see here, how many steps? Right now we're set to 3. 1, 2, 3. If we want that same region here to go into 5 or 6, this is where we would change that. Step width, how wide are they? So right now they're about 200 milliseconds. But if you want to make these wider, that's what we would do. So your step pulse is actually going to be longer. Start height, it's at 0 right now. You could change it to 1 if you want to, whatever you want, but this is independent of baseline as well. And of course the end height. Where do you want us to be after our number of steps have been accomplished? Next is going to be step pulse. The same, but we're actually doing a full reset to baseline between each step. So baseline, still the same, start delay, repeats, max repeat rate. How many steps we want? Just like the previous step output. The step width, the start height, the end height, and then there's the pulse width. The step width is here, and I'll move the marker out here, and we'll kind of talk about what that means. And I'll drag a DVM out here so we can kind of see. So as I mouse over, I'm probably off a little bit here. Oh, wrong one, sorry. Let me drag out the time here is what I'm looking at. So you can see our little pulse width is roughly 100 milliseconds here. But between the start of that first pulse and the start of the second one is 200 milliseconds, and that's what we're talking about here. The pulse width, our little pulse right here, 100 milliseconds, but the width between different steps is 200. So if we change this to 200, and let me get rid of my markers so we see things, it'll look just like the previous step output. But once we start changing that back, sorry, went the wrong way there. We'll go back to our step pulse. So once again, step width is going to be the time period between starts and stops. Pulse width is going to be the width of the actual pulse that's being, or excuse me, of the different starts for each step. And this will be actually the pulse that occurs within that step, how wide it is. Moving on, biphasic pulse, just like it sounds like, positive and negative, positive and negative. All of the oldies but goodies here, baseline, start delay, repeats, max repeat rate, pulse height, and pulse widths for each one. Double pulse, just like the name sounds. All the old ones that we've had before, but now we have actually control over the pulse 1 height, the pulse 1 width, the gap width between the two, and the height. So we can kind of tell, well, how large do we want this gap between the two pulses? Right here. And we can tell it here of how wide we want to make that. So let's just do something outlandish. And now it's 1 second between each one. Ramp, just like it probably sounds. You ramp up, drop down. All the traditional ones that are with every other waveform, baseline, start, delay. Segment repeats. We can do one, we can do many. Start height, and the length of each individual ramp right here. Sine wave, obviously we're going to have cycles instead of max repeat rate, but the number of cycles that you want to occur, we can set here. Frequency and amplitude. So as we have it set up right now, it's infinite, but if we said, oh, well, we only want like 1 cycle, we'll stop it, start it. It only does 1 cycle of a 1 hertz sine wave and then stops. Or we can do infinite. And this is actually repeats of the whole segment that we're doing. So if I was to do 2 repeats here of 2 cycles, we did 2 cycles of at 1 hertz, did it twice, and then stopped. So that's kind of what the repeats means here, as well as the cycles. Triangle is very similar. All of that is available to us. The only thing we have here is skew, which goes between -1 and 1. So I'm going to go ahead here, and basically it'll make it, if we go all the way to 1, it'll make it look like our ramp. Or if we go all the way back to -1, it skews it back the other way. It makes it pretty much a reverse ramp. And then we go back to triangle standard. So these are the basics. These are all preloaded waveforms. These are things that you really won't have to do much. Everything's pre-programmed in here for you. I was also saying that I was going to kind of talk about this interface right here and how to change it. So we've kind of talked about how to enter in values. We can type them in here. We can use the up and down arrows if we want to, and we can also use the slider. But say these default parameters don't work for us. We want something a little more fine, something a little different. You'll notice this little icon on the right-hand side here for each parameter. If we left-click that, it brings up the control settings for that parameter. So here we have baseline. If I go down here and click max repeat rate, we get that. So I'm going to go back here to baseline. So I can actually go in here and change it now. So say I actually maybe want something a little different than what we've been seeing. So I'm going to -2 to 22. We can do a logarithmic scale. Sorry, being a little bit too high there. We can do a logarithmic scale, or we can do a linear scale that we can break up into the number of steps or into specific voltage increments. Neither is wrong, and you'll kind of see that as I update the steps, the increments value changes, and if I update the increments, the number of steps updates. So if I hit OK, now we have -2 to 10, and that's just the way you're going to be able to change things as you go through. I'll go ahead and turn the logarithmic on, which kind of takes away, of course, our linear steps, and you'll see that we actually kind of have a logarithmic breakdown. hash marks down here. You'll see some of them are default that way for instance, frequency, logarithmic, cycles, logarithmic as well. Or we can go back. And also, with a lot of LabChart interface windows, things like this, you'll see the little question mark button here. And what this will do, if we left click on it, it will take us to the help menu and actually tell us what we're doing here. So if you're a little confused about something, definitely worthwhile to click on that. So that kind of takes us through the basics of what we're doing here. I'm going to go ahead and close this and actually close this file to kind of set us back to where we need to be. So that kind of covers the basics of the stimulator. Preloaded things, very straightforward stuff to do. You're not getting too deep into a lot of the power of the stimulator, but very, very rudimentary. You can use this just straight away. There's no real learning curve for this. Now we're going to kind of go into a little bit deeper some of the more powerful features of the stimulator, and we're going to kind of talk about the customizable waveforms dialog. You can create complex chains of preloaded waveforms with the Customize button, and this will allow you to kind of stack different ones together. So say I want a pulse followed by a sine wave, followed by a triangle, followed by a biphasic, followed by a pulse again. We can do that, and we can make it kind of stretch over really long time periods. So we're just going to click here on Customize. Once again, this button right here. And it just takes us a little bit deeper. We're actually in the stimulator waveform customization window now. So like I said, we can add other things. So by default, we had it on pulse. It's just going to give us our pulse according to how the defaults are set here. But say, for instance, I want to do a sine wave after that pulse. You do a sine wave after that pulse. Then I want to do a triangular pulse. We can do that. Then I want to go ahead and do a step. So I hit OK. We'll kind of move things to the side here. I hit Start. And there's our custom waveform. So obviously a lot we can do here. We can make some very interesting waveforms out of this. And going back, once again, to access that, we got to customize. If you don't save this or name it, you'll just call it a custom output or custom dash output 1. And you can actually go in here, remove specific portions of this. And if it gets to be too many in one spot, it'll actually just give you a little down arrow here and kind of collapse them on each other, and then you can select them from a list. How many of these different segments can I put together is always the question that usually gets asked first. You can do 20 different segments within this window for one whole custom waveform. Looking at the window can be a bit confusing. The thing to always remember, I'm just going to go ahead and get rid of a bunch of them and go back to our original. These parameters up here, and let me get my little drawing tool, are for the whole waveform itself. The baseline of the whole waveform that we've created down here in this window, the start delay, how often we want it to repeat, the match repeat, et cetera, et cetera. These down here are for the individual segments. So let me get a few more segments in here. Again. And we'll just add a couple. So you see, as I go to each different one, these parameters change. So all of this down here is for the specific segment we have highlighted. This up here is for the entire collection of segments in the custom waveform we're doing. Whenever we have a marker set up, a marker channel for the stimulator, so this guy right here, it's going to drop a unit spike at the beginning of the waveform. So at the beginning of every one of these, it would put a unit spike. So it would put a unit spike here, here, here. It won't do it for each individual segment. It will do for the whole waveform we've created. when it starts again. Like I said, once again, overall waveform parameters up here, and also down here is for the individuals, and down here is for the individual segments. And it'll actually tell you segment parameters, number 1, pulse 1. Although we want to work on the step, segment parameters, number 4, step. You'll also see we have the slider options available here. So once again, we can go in and change the different parameters, the ranges we want to use. But you'll also notice we have these panel and dialog checkboxes. What this means, if I check the checkbox for dialog, it will appear out here. That specific parameter will appear out here in the main stimulator settings window. If I click panel, it will occur out in the stimulator panel, as you would probably imagine. So for instance, say I don't want any of these, or I don't want the pulse height to show. So these two values, I don't want them in the panel. I uncheck that, I hit OK. Panel updates, we remove those values from the panel. They're still here because I left them checked in the dialog, but they no longer show up in the panel. So that's just a way you can add the parameters that are important to you, once again, while you're recording, that you need easy access to change immediately. So there is another layer to this, and that would be the arithmetic function. So I'm going to go ahead and delete all of the little ones that we made here. We'll close things and close our panel and go back to customize. And I'm going to go ahead and delete the one that's here. You'll see there's this little button here that is FN. So basically, it's just a symbol for an arithmetic expression. So if we click that, we get an example one. And you'll see down here for this segment, we have this expression. And it uses a syntax very similar to, say, like a TI-89 or a scientific calculator. We have a basic, just saying it's a sine wave, and then each position inside the parentheses represents a specific parameter of that sine wave. If you want to get very complex with your stimuluses, this is what you would do. So I'm just going to kind of show what this one looks like. So we have a basic sine wave. Its amplitude and its frequency are being varied according to triangle waves. Or excuse me, its amplitude will always be 100. We're using a triangle wave here. I'll have to look a little bit closer here. Sorry. So we're using a triangle wave to vary the frequency, and we're using an exponential decay to actually go ahead and decrease the amplitudes. And of course, we have a kind of a multiplier here to kind of take care of any other effects that may have. So if I hit OK, we start it. Let me open things up a little bit. You'll see we just keep repeating that. And I'm going to go ahead and drop a marker here on channel 2 so we can kind of see how that works. So you can see every time we repeat that whole waveform, we drop a marker. And if we wanted to, we can still go in here and add some of the preloaded ones. So for instance, we're going to do a step. I'll hit OK. We got a step at the end. My mistake, it's actually dropping a marker in for every segment here. Telling us when everything is repeating. So just a very in-depth way of going in and changing things, very customizable. So I'm going to go ahead and delete this. Now, you're curious, well, what does this mean? How do I get help? What is the syntax for the different dialogues or the different equations, we can go ahead and look those up actually in the help menu. So if I go to index here, do a search for stimulator, and you can see here we have an arithmetic option. We go to that part of the subject, and we have expressions that we can use. Counts. Well, how do I create a square wave pulse in there? Here's how you do it. Pulse. This is what each individual position in the parentheses means. Amplitude, width, start delay, end delay, repeats, etc., as we go down. And they'll be there for everything. And you can go ahead and combine those, nest them with inside of each other if you want to use another expression to control amplitudes, frequencies, stuff like that. So once again, you can do it there. And of course, we can access waveform customization here, segment types, whenever we hit our little question button down here in the lower left-hand corner of the window. So I have a little preloaded waveform that I put. So I've gone in here, we're going to go into customize and kind of show you what it did. The sine wave expression, we'll have it down here. The way it works is we have the frequency will be the first position, will be the amplitude, and I'll talk about why I can type amplitude in here. The phase that we start at, I'm going to use the default of 0, and the number of half-wave repeats. So ignore this expression at the end here. I'm going to use it to kind of show how the stimulator panel can be used to affect things in real time. But if we look at it here, what does half-wave repeat mean? Well, it can mean this. So I have a half-wave repeat here. If I go to 2, click out of there, I get another half-wave repeat. So we have a full wave. If I go to 3, that's what it does. If I change the phase, you'll see we'll start moving where we start with the sine wave. So different ways that we can go in and change things. We're also seeing my exponential decay kind of affecting things here. And we'll kind of talk about that in a little bit. So I'm going to go back to how I had it. So I just have this exponential, just like we would in like in a TI-89 or some other scientific calculator. I have a variable in here that's being operated on by time. So variables, what does that mean? How can you just type in a word here? You can see here, if I go up to the waveform parameter, I can actually create custom variables that I can change or have default values, so I can change them later on in expression. So I'm not giving a constant in here. I can change it on the fly, like say out in the stimulator panel, and change how things work. So amplitude, of course, is going to be the amplitude of the sine wave. I have it default to 5 volts. Q is actually our little exponential variable here to kind of change how heavy that decay is. You can see here, just like with other things, we can actually tell it to be in the panel, be in the dialogue. We can change parameters about how, what the ranges are. And the way we add these or remove them, so for instance, if I wanted to delete Q that's being used right now, I could go ahead and just do a minus right here, or amplitude. I could go in here and just delete. Say I want to create a new one, add parameter. We can call it frequency, and we'll say we'll leave it at expression of 1. I hit OK. We get our new frequency one. I can now go down here and add it to our equation. Make sure I use the syntax exactly. And now we actually have a variable in there instead of an actual constant. I can also have that appear in the panel or appear in the dialog. So either appear out here or actually in the control panel. Or see me the stimulator panel. So we've added a few here. say I don't want that one anymore. We can delete it. Remove it. We're going to have to go in here, of course, and remove frequency from there. But we'll go ahead and okay, see, now it's erroring saying frequency is not a recognized function or variable. Go ahead and put 1 back in there. Everything's right. So we'll create it again. Have it default to 1. Once again, we have our question mark box here that we can actually go and look at a help topic if we forget what we're doing here or what we exactly need to do. Hit OK. I'm going to have this show up in the panel. We'll enter it again into our equation. And we'll go ahead and go to here. All right. We can also set the duration of this window we're seeing here as well. We can set delays in here if we want to. I'm just going to kind of leave things kind of basic here. So if I wanted to, I could say, well, I want to see 3 for that. That needs to have a duration of 3 seconds, and we get our 3-second duration for the waveform, or for this segment, I should say. And I can say stimulator event at start of segment or not. That's why we were seeing it before here. We could uncheck that and just have it at the beginning of the waveform, or for specific segments within our expression. So say we want a stimulator event here, we can say no, yes, but we don't want one here. So it'll tell you at what point you are on that segment of the waveform. You can add events there. So to kind of show things how it works out here and how the panel works, we'll hit OK. We'll have this save as our sine wave. We could name it something else here if we wanted to. And it appears. What you're seeing here, that they're doubled, is just a slight issue in the software that we're aware of and we're actually working on. The names get repeated, but it doesn't matter whichever one you click on, you'll go there. If you update this one, it'll update the other one as well. But I'm going to go to my new sine half wave. We'll close this. We'll go up and bring our stimulator panel up. You can see here we have amplitude, frequency, and our Q, or actually multiplier of that exponential decay. So we're just going to make this 0 right here so that exponential decay won't occur. We hit start. We get our little half wave, 3 seconds, half wave, 3 seconds, half wave. I want to start decaying that, we'll say. So I go to 1. Not quite enough yet. Oh, there we go. Yep, started updating. You can see we're changing now. It's starting, that exponential decay is starting to affect our half wave that we're generating. Go to 3. Changed right in the middle of a pulse. You can see we're starting to kind of decay that portion of the half wave now, even more. Let's go to something a little bit ridiculous, 10. And it starts cutting into even more as that decay starts getting closer and closer to the start and more severe. Or we can go back to 0. Update, and we're back. So stimulator panel, way you can control things while you're recording, much easier. We can turn the stimulator off, turn it on, and also go down here and affect the second one as well. And last but not least, we'll kind of show you how customizable it really is. Everything I've done here is actually relatively simple. This is a example file for the stimulator that our developers put together. And I'm going to go ahead and here and kind of pop things open. It's going into channel 1. It's a custom setting just to kind of give you an idea how complex this expression is. We have multiple variables in it. We've also have a variable in here, f slow, that is actually another expression. So you can nest them with each other. We have these different variables in here, and you'll kind of see how it's varying the sine wave expression right here. Right now we're just not zoomed in enough, I don't think, to kind of see what's going on. So we're getting that kind of constant blue here. And they've made the duration, they moved it to auto, so it fits like it should. I'm just going to cancel out of here, and we'll kind of show you what it does. Now, on the left here, we have our spectrum view, which will actually show you how the frequency of the signal coming in is changing over time. So you can see here, we have actually developing different frequencies within the wave that we're outputting, and it's oscillating back and forth. We also have our pretty color spectrogram down here telling us how things are changing over time as we're recording. So we have different harmonics, and like I said, again, they go into 1, and we start spreading out again, or different combinations of sine waves coming together, and they're oscillating according to time. So very powerful feature with the stimulator. You can do a lot of things with it, and the addition of this customization with the arithmetic functions adds a whole other level to it. So I would highly recommend that you experiment with it, give it a try. Like the slides you can kind of see here, the sky is almost the limit as far as what you can do with it. So that kind of brings us to the end of all the topics that I wanted to cover. Let me go ahead here and bring up my slideshow. So that's it for today. If you have any questions, feel free to call me. My telephone number is up here, 888-965-6040, extension 204. You can email me. I'm on Skype all day as well. So if you have any questions that maybe you forget to ask today, or if you think of something later on that you might want to try to do, or think there might be a problem with the hardware or software, anything to happen with us, I'm technical support for North America, so give me a call. We can talk it over. If I can't answer it, I have the ear of our software developers as well as our engineering department, so we can talk to them and kind of go back and forth to see what we can do. So on that note, I'll leave that up for right now. It looks like we do have a few. We have one question. Let me drag this out here so we can see. So is there a provision for setting train? So train frequency, train duration? Most definitely. You probably kind of maybe saw that when I was putting things together here. So if by train you mean a specific segment, we can definitely change that within. The customize option. So say for here, well, I wanted more than that many pulses. Well, I can do that according to this. Say 5. What frequency do I want, or what delay do I want? We'll do. We can just slowly change that. You'd have to kind of calculate here the periods if you wanted to do it this way. Of course, you wouldn't have to go in here to the customization. You could just do that out here in the general settings, but sometimes it's easier to see the segment in this view and actually kind of see what you're changing and doing. You could also add multiple segments like this if you want to do specific things with amplitude in that train. I hope this is answering your question here. If not, definitely put something into the questions again here, or we can talk about it later offline. So you can see I have an end delay there. We go to 2, put another end delay in here. end one and put another end delay in here. Can you kind of go in here and just a simple value, type it in? Maybe not. Let me go ahead and get rid of these. Go to pulse. We could do repeat rates here if we wanted to change the kind of frequency, how fast this occurs. So for the overall waveform, all depends on how you want to tweak it. There's a lot of different ways to do it. I think this is what you're getting at by train frequency and train duration. Of course, duration is going to be affected by how many pulses we tell it to do and how much of a delay there is between them. So a lot of different settings that you could use to change those. So Dr. Dev, if that doesn't answer your question, feel free to give me a call and we can talk it over some more in further depth. Or if you go ahead and try to implement this and might run into any problems, feel free to give me a ring. So I'm going to go ahead and minimize LabChart here once again. Here's my contact information. I'm not seeing any other